This video, we're going to talk about 2.4 elementary matrices. So let's go ahead and get started by looking at number 1. And it asks us to determine whether the matrix is elementary. If it is, state the elementary row operations used to produce it. So an elementary matrix is going to be one which can be obtained from the identity matrix by using only elementary row operations. So we have 1, 0, 0, 2, and that is an elementary matrix which can be obtained from the identity matrix 1, 0, 0, 1 by multiplying row 2 times 2. So elementary multiply, I'm just going to say 2R2 to produce a new R2. Multiply row 2 by the constant 2, right? So 3 is going to be 1, 0, 2, 1, and that is also elementary. And that's going to be 2R1 plus R2 to produce a new R2. Will be the elementary row operation that's being done there. So number 9, find an elementary matrix E such that EA is equal to B, where A is equal to 1, 2, negative 3, 0, 1, 2, negative 1, 2, 0. B is equal to negative 1, 2, 0, 0, 1, 2, and 1, 2, negative 3. So elementary matrices tell me the row operations that I did. So I swapped row 1 and row 3 in A. So E is going to swap row 1 and row 3 in the identity matrix. So row 1 is normally 1, 0, 0. I'm going to put that at the place of row 3. Row 2 got left alone is normally 0, 1, 0. And row 3, which is going to the place of row 1, is 0, 0, 1, like that. So that's my elementary matrix. Let's go ahead and this is swap rows 1 and 3. Get to number 15 now. It says to find a sequence of elementary matrices to write the matrix in row echelon form. So number 15 is going to start with one, negative 2, negative 1, 0, then 0, 4, 8, negative 4, negative 6, 12, 8, 1. So we've already got the 1 in the leading position, the 0 beneath that, and we want to get a 0 beneath that. So we're going to want the row operation would be 6 row 1 plus row 3 to produce a new row 3. So my E1, my elementary matrix that does that, I'm going to take 6 times row 1, which would be 1, 0, 0. So 6 times that is 6, 0, 0. Add that to my row 3, which is 0, 0, 1, and I get 6, 0, 1. And these remain unchanged. So that's going to give me a new matrix down here, 0. 6 times negative 2 is negative 12, plus 12 is 0. 6 times negative 1 is negative 6, plus 8 is 2. 6 times 0 is 0, plus 1 is 1. Leave these alone. Now I want to get a 1 in this position, so I need to take 1/4 of row 2 to produce a new row 2. So my E2 is going to be 1/4 of row 2. like so. And that's going to produce 0, 1, 2, -1. Now, I need to get a 1 in this position here, so I need 1/2 of row 3. So my E3 is going to be 1/2 of row 3. That gives me 0, 1, 1/2, 0, 1, 2, -1, 1, -2, -1, 0. So I'm in row echelon form where I have ones and zeros underneath them, that the first non-zero entry of a row is a 1, and all the uh, rows underneath that have zeros. So this is in row echelon form. I'm done. So that tells me that if I go in reverse order here, I need E3 times E2 times E1 times A needs to be equal to this 1 here. So let's go ahead and write that out. My E3 is 1, 0, 0, 0, 1, 0, 0, 0, 1/2. And my E2 was 1, 0, 0, 0, 1/4, 0, 0, 0, 1. And my E1 was 1, 0, 0, 0, 1, 0, 0, 6, 0, 1. And that gets multiplied times my original 1, -2, -1, 0, 0, 4, 8, -4, and -6, 12, 8, 1. And that will produce 1, -2, -1, 0, 0, 1, 2, -1, 0, 0, 1, 1/2. Go ahead and prove that to yourself if you want to, multiplying these out, but that is how that works. Let's go ahead now and look at number 17. And it asks me to do the same thing here. Start off with -2, 1, 0, 3, -4, 0, 1, -2, 2, -1, 2, -2. The first thing that I notice is that these rows are opposites. So I'm going to get a row of zeros by adding row 3 to row 4 to produce a new row 4. That's going to give me 0, 0, 0 on row 4, 1, -2, 2, 3, -4, 0, -2, 1, 0. My elementary matrix that does this is going to be adding row 3 to row 4 is going to be 0, 0, 1, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0. So it's a 4 by 4 because there's 4 rows. But I'm going to take what was normally 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, and 0, 0, 0, 1. And I'm going to add this 1 to that 0 to make a 1 there in the third position in row 4. Now I want to swap row 1 and row 3. So my E2 is going to be row 3 becomes this, and row 1 becomes this, and row 2 stays the same, and row 4 stays the same. And so I'm going to want 1, -2, 2. And then this is -2, 1, 0 there. All right. So now we've got that 1. We're going to use it to get zeros beneath it. I can do more than one step at a time and get an elementary matrix here. So -3, row 1 plus row 2 to make a new row 2, and 2, row 1 plus row 3 to produce a new row 3. We can take care of those both with one elementary matrix here. So we're going to leave row 1 alone. And row 2, we're going to add a -3, row 1 to row 2. And row 3, we're going to add 2 times row 1 to row 3. And then row 4, we have left alone, like that. So that's going to give me 1, -2, 2, 0, and then -3 times -2 is 6. 6 minus 4 is 2. -3 times 2 is -6. -2, or I'm sorry, 2 times 1 is 2, plus -2, 0. 2 times -2, -4, plus 1 is -3. 2 times 4, 2 times 2 is 4, plus 0 is 4. Keep these zeros down here. Now I have, I want to get a 1 here, and so honestly, I think the easiest way for me to do that is to get a -1 by adding row 2 to row 3 and then change the sign after that. Let's see if that's what I did. No, I just divided by 2. So 1/2 row 2 to produce a new row 2. So that makes E4, 1, 0, 0, 0, 1/2 of row 2. Okay, so that's going to make this 1, -2, 2, 0, 1, -3, 0, -3, 4, 0, 0, 0. Now I'm just trying to write this in row echelon form. I'm not trying to get all the way down to reduced row echelon form. Still have a couple more steps though to get it in row echelon form. So we're going to multiply 3 times row 2 plus row 3. And this makes E5, which is 1, 0, 0, 0, 0, 1, 0, 0. So row 3 is 0. There's a 1 there, 1 row 3, and 3 row 2s, like that, and then 0, 0, 0, 1. So we have, that's going to give me 1, -2, 2, 0, 1, -3, 0, 0, -9 plus 4. It's -5, 0, 0, 0. The last thing that I need to do is get a 1 in row 3. That's going to be -1/5 row 3 to make a new row 3. That's going to be E6. It's going to be -1/5 row 3. So -1/5. -1/5 row 3, like that. And so I have 6 elementary matrices there that I should be able to take E6 times E5 times E4 times E3 times E2 times E1 times matrix A to give me my answer of 1, -2, 2, 0, 1, -3, 0, 0, 5, 0, 0, 0, which is matrix A in row echelon form. So let's see if I can write out that left-hand side. It's quite a bit to write out here, especially since they're 4 by 4. So 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, -1/5, 0, 0, 0, 0, 1 times, that was E6. E5 is 1, 0, 0, 0, 0, 1, 0, 0, 0, 3, 1, 0, 0, 0, 0, 1. That's my E5 times my E4, 1, 0, 0, 0, 0, 1 half, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. That's E4. Then E3 is 1, 0, 0, 0, -3, 1, 0, 0, 2, 0, 1, 0, 0, 0, 0, 1, E3, 0, 0, 1, 0. This is me swapping row 3 and 1. So this is 1, 0, 0, 0. And so this is 0, 1, 0, 0, 0, 0, 0, 1. It's my E2. My E1 is 0, 0, 1. Here, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. Okay, now all that multiplied together times original matrix A of -2, 1, 0, 3, -4, 0, 1, -2, 2, -1, 2, -2. All that is equal to final answer of 1, -2, 2, 0, 1, -3, 0, 0, 1, 0, 0, 0. On to number 21. We're starting off with 0, 0, 1, 0, 1, 0, 1, 0, 0. This is an elementary matrix. E. I want to find E inverse. So what undoes this and gets me back to the identity matrix? Well, to undo it, I would need to swap row 1 and 3. So what elementary matrix is going to swap rows 1 and 3? The same thing, because rows 1 and 3 were already swapped. So I just need to undo the swap to get back to the original. So it is its own inverse in this case. Let's go to number 25. And it asked me to find the inverse of the matrix using elementary matrices. So 25 is A, let's call it is 3, -2, 1, 0. So we're going to use elementary matrices to get down to the point where we have the identity matrix. So we're going to swap rows 1 and 2. So E1 will do that for us. And row 1 and 2 get swapped. And so now we have 1, 0, 3, -2. Now I'm going to take -3 times row 1 and add it to row 2. So -3 times row 1 added to row 2. That gives me now I need -1/2 times row 2. That'll give me 1, 0, 0, 1. So now I'm ready to write A inverse. So A inverse is going to be equal to and write these in reverse order here. 1, 0, 0, -1/2. 1, 0, -3, 1. 0, 1, 1, 0. So not times the matrix, but just write those like that in that order. So A -1 is equal to, and then I'm going to go left to right here. So this is going to be 1 plus 0. This is 0 plus 0. This is 0 plus 3/2. And this is 0 minus 1/2. And that's going to be times 0, 1, 1, 0. So that's going to be 1, 0, 3/2, -1/2 times 0, 1, 1, 0. And so A inverse is going to be 1 plus 0, 1 plus 0, 0 minus 1/2, 3/2 plus 0. So that's going to be 1, 1, how did I say 1? That's 0. 0, 0, 0. So this is 0, 1, -1/2, 3/2. Which is right, it should just flip-flop the columns there. All right, and then we have 27 will be our final problem for this video. And we have 1, 0, -1, 0, 6, -1, 0, 0, 4. So we want row operation here, 1/6 of row 2 to produce a new row 2. And while I'm at it, 1/4 of row 3 to produce a new row 3. So that's going to give me 1, 0, -1, 0, 1, -1/6, 0, 0, 1. And my elementary row operation to do that is 1/6 of row 2 and 1/4 of row 4 or row 3. So there we go. And then I'm going to add, I'm going to take 1/6 of row 3, add it to row 2 to produce a new row 2. That's going to be 0, 1, 0, 1. Also going to take row 3 plus row 1 to produce a new row 1. That's going to be 1, 0, 0. And my E to do that is going to be, so row 2 is going to be 0, 1, and 1/6. And row 1 is going to be 1, 0, 1. Adding a row 3 to a row 1 to produce a new row 1. And row 3 got left alone. And so that gives me an A inverse of E2, 1, 0, 1, 0, 1, 1/6, 0, 0, 1 times 1, 0, 0, 0, 1/6, 0, 0, 0, 1/4. So that's going to give me 1 plus 0 plus 0, 0 plus 0 plus 0, and then 0 plus 0 plus a fourth. Then we have 0 plus 0 plus 0, 0 plus 1/6 plus 0, 0 plus 0 plus 1/24, 0 plus 0 plus 0, 0 plus 0 plus 0, 0 plus 0 plus 1/4. So that's going to give me 1, 0, 1/4, 0, 1/6, 1/24, 0, 0, 1/4. That's going to be it for this video, and we'll come back next time to talk about 3.1, which is the determinant of a matrix. See you for the next video.